Now register file experiment, which is, let's say it's an xp5.asm. And now remember we had our CS47 underscore macro.asm we have created in last lecture. Include that in this file and write a program using li sudo instruction, which is like load immediate, to load all the register from 0 to RA with number 1 to 32, and use macro exit to exit from the program. Example li0, 1, that will move this immediate value 1 into register 0. And we'll put a breakpoint at the exit and run the program. Observe that change in the register 0 cannot be written. We'll observe the change in the registers and we'll see that 0 cannot be written. It is always 0. Then we'll do the same program, which we'll call it exp65, but using the register numbers. And observe the number are not convenient to remember for the purpose of the registers. So that's the whole purpose of this experiment 6.asm. Okay. So before we move into that, maybe I should show you these two programs what I have written. You probably want to practice because that will give you an idea what are the registers name, and you can like fluent in typing the registers names and so on and so forth. And experiment 6 is to prove the point that even if you want to use $0, $1, they seems like convenient at the very beginning, but it is not, because they don't carry kind of an extra notion that what is the usage of those registers. So I have opened up this function already, this Mars IDE. Let's say, yeah, this is xp75. So it is nothing but like just include the CS47 underscore macro.asm file, and on the text have a level main. Just is a good practice to start something with a main, your start of your program. And then it has bunch of li0 is 1 and 82, v03, etc, etc, etc. And from the name we know, okay, this is 0 constant, this is assembler temporary, this is like an value returned from the function, these are argument register, all the $a number registers are to pass argument to the function. Then anything with a t, they are temporary, not preserved across the function. All the s, they are preserved across the function. K is for operating system kernel, gp global pointer, sp stack pointer, fp frame pointer, and RA is return address. So from the name we can guess their usage, right? Let's assemble it. So you see li becomes some pseudo instruction for us. At the end it becomes an exit, become 2. This is the macro exit. It becomes a syscall and another basic program, and we just can, okay, let's make a breakpoint here, or what we can do is basically step through, right? So add I, first was what, li load immediate 0 to value 1. So here is my register, which value I am expecting to be changed at 1. But what we will see, first of all, remember, like assembler is successful, like it didn't complain that hey, I cannot write to 0 or something. It's fine. Then we do a step, it completed. See, the result is unchanged. Result is still 0. So it is not that there is something wrong with the instruction. It is just that processor does not care what you request to write in the 0. It's just keep it to 0 always. Okay. The next li 2 at 1. See that 80 value changed to 2. We can do it, and then 3, then 4, then 5, then 6, 7, 8. So I'm just keep on going writing to all of these register one by one, and we can write into the K0, K1. I can write into the GP, no problem, SP, no problem. It is only the convention of the program that kind of, if you do it like override these values, you will run into problem at future time. But this is so simple program, it is not using any other person's module or code, so you're okay. We can override it, still leave our day on this part. And also see, like after array there is PC high and low. PC we are changing it value indirectly by next instruction, etc. High and low we haven't touched, we'll talk about this. Okay, so this is the your program, and program is finished and we're done. So now this experiment 6, which is like very similar to this one and seems almost like why we need to do that, but point is this, you see my all the register are written in a number. So if I am writing this in a number, it's kind of lost a notion, lost a way to remember what this register purpose is, right? Just look at like 16. Okay, I don't know what's the purpose is, right? Compared to that, if I look at here, like okay, S3, it may not be the 16, but okay, whatever, S3 is okay, that's a saved register. I can save a value there, call a functions, and I'll expect that value will be still there after the function call is done, function is done. So that's my easiness of writing assembly program, which I don't need to remember much about details about, except the names. Okay, name will tell you the purpose intuitively, right? So, but it's still the same thing. It just, you can assemble, is the same basic codes. You run it, you see all your numbers are changed, and then 0 is remain unchanged. So it's the same experiment. Okay, so this is your these two experiment. Please try it. It is your very first assembly program, probably. May not be. Your programming assignment is due before that even. We just started to writing with the macros. But anyway, this is kind of when you are writing a program from a main level, right? It's not the macro writing, it's a main program writing. So please do that. It's kind of little bit time consuming, but well, it will give you enough practice to kind of writing the register snap.